Okay, so we're hearing more and more about artificial intelligence. I mean, it's everywhere, isn't it, in the news and in our daily lives, of what's going to happen, etc. But it'd be good to understand specifically for our conversation how AI is driving change in terms of data center architectures. That'd be a good place to start.
Yeah, absolutely. Artificial intelligence is really driving a profound transformation in data center architectures. And we're seeing that particularly among the hyperscale companies, the large ones who are implementing AI clusters for training, developing those training and high compute models. And this is really characterized by a number of pivotal shifts. Hyperscale data centers, they're really rapidly expanding to accommodate this immense computational requirement that these AI workloads require. And they're deploying specialized hardware such as high performance GPUs and TPUs to make that happen. And then there's also the real-time data communication aspect that's critical, that's required between nodes within these AI clusters. And those require high-speed, low-latency network technologies like optical interconnects and low-latency switches. Additionally, there are specific hardware accelerators that are required for AI, and those come with GPUs, TPUs, and FPGAs that help accelerate the machine learning and deep learning tasks. So as we see these increased computational demands, that also requires careful consideration of power and cooling infrastructure to optimize the performance, while also at the same time minimizing the energy consumption. So AI is really reshaping the hyperscale data center architecture, and we're entering this new era of scalability, performance, and efficiency to meet those demands.
Okay, and in terms of outlining some of the unique challenges, I guess, that the data center faces when it comes to particularly cabling and connectivity, as they seek to integrate these AI technologies outlined, it'd be good to understand, how that sort of landscape is looking.
So first and foremost, it's important to understand the architecture of AI networks. They're really designed to process vast amounts of data, and due to the structure of these learning models, they often consist of many, many nodes that require extensive interconnections to adjacent nodes. So there's an additional level of complexity that places substantial demands on the cabling infrastructure to help facilitate those seamless and high-speed communications between those nodes. And then taking a step beyond network architectures, there are some additional challenges to address. So I spoke about the increased power requirements that these AI workloads require, especially those utilizing the high-performance GPUs and TPUs. And that requires robust power delivery and the enhanced cooling solutions to prevent overheating, as well as maintain the reliability of the hardware components. And then when we look at that from a fiber infrastructure standpoint, the challenges are equally daunting. They generate and process data at an unprecedented scale, which leads to the need for extensive volume of terminations and connectors. And then when we think about the density of connectors within that fiber infrastructure, we have to be careful to manage that as data centers really drive towards that higher density required within a limited amount of physical space. And that requires a lot of innovation to make sure that we have that efficient cable organization and management in place. And then think about the sheer bulk of cables that's required to interconnect all of these nodes. So as we have all of that cable in our data center pathways, in our cable managers, that poses a logistical challenge as well. And as we look at this, we can think about the congestion within the pathways and cable management systems. And that not only impacts the cooling and airflow within our cabinets and racks, but also makes accessibility for maintenance and troubleshooting a challenge. So to sum it up, really, as we look at the integration of AI technologies in these hyperscalers, there are multifaceted cabling and connectivity challenges. And it begins with understanding the network architecture, then accommodating that and processing the vast amounts of data that require that intricate connection and the scale and sheer number of terminations, while also addressing the power and cooling requirements.
Okay, so I mean, you've outlined there quite a complex set of challenges, for the data center owners, operators to understand and address. So it'd be good to understand, there's the problem you've described. What are the solutions? How do they go about addressing some of these challenges?
Yes, so from an AFL standpoint, we've been very fortunate to be a manufacturer of both the optical cable as well as the connectivity. And this allows us to address the challenges presented by the fiber infrastructure and the AI explosion in a few ways. And that helps to significantly improve the performance and efficiency of AI-driven data centers. So as we look at the density of the connectors and cables required, that's a critical concern. So on the connector front, we have seen innovative connectors like Fujikura's MMC connector or Senko's SNMT connectors. They reduce the connector density by a factor of 3. And looking at the cable side, we've made some innovative progress in both reducing the fiber diameter, like our new 80 or 160 micron optical fiber, and also improving our cable designs. So that helps us manage the high density requirements, making more efficient use of space and pathways. And the reduction cable diameter not only lowers the weight, but also optimizes cable tray space, which is critical with the amount of infrastructure that's required in these clusters. And then another important point to make, there is the growth in connector termination capacity that's required. As we look at the increased amount of connections and the sheer density of the connections, that is growing exponentially. So at AFL, we've proactively expanded our global termination capacity for a number of years now and have made significant investments in this area. And this is a commitment that allows that we can meet the escalating demands for this high density cabling solution that is required in AI data centers.
And I know earlier in the conversation you referenced particularly the hyperscalers, getting to grips with this. But I'm also wondering what's the relevance of AI-driven data center infrastructure to most enterprise customers, and are you finding that they are adopting AI technologies that already require the kind of infrastructure that you've outlined?
Yes, certainly. On the enterprise front, AI is having a significant impact. And that's really where the hyperscalers are investing heavily to also support the enterprise. Obviously, there's transformative potential in enhancing enterprises' business operations, their competitiveness, as well as helping them to innovate. And many enterprises are starting to adopt AI technologies, or they're planning to do so within the near future, which requires that infrastructure capable of supporting those workloads. And the size and scale of that infrastructure will vary depending on the use case and really the discipline and market that the enterprises are looking to address. But as we kind of think about the traditional on-prem data centers that enterprises own, there are significant preparations and things to think about for the enterprises. As we've learned, those networks require specialized hardware, high performance compute resources, and that low latency network, which can have significant impact on their capacity planning, but also the investment that's required. And then the enterprises also need to think about the scalability, the power, and the cooling requirements to accommodate those networks, especially if they anticipate growing their AI workloads in the future. So as we see AI technology maturing and becoming more accessible, I believe that many enterprises will find themselves adopting those solutions, but they may also partner with hyperscalers or adopt a hybrid model to facilitate that. It's important to recognize that, however, the infrastructure technologies that are currently deployed by the hyperscalers, like the very small form factor connectors, there are likely going to trickle down to the enterprise market as well in the coming year.
I suppose maybe if I can just ask in summary, how big an impact, I know everyone, as they talks about AI, just how much of an impact do you think it's going to have on the data? And, is it something of a revolution? Because, traditionally, okay, the servers are a bit faster, they might need a little bit more power, a little bit of cooling, but this high density, high compute environment, I don't think we've seen it quite like this. So do you think there's going to be a major sort of getting up to speed for everybody?
Certainly so. As we've termed it, the AI revolution will have an exascale impact on the hyperscalers. So as we look at hyperscale, think of it in terms of increasing to a whole nother level. So to achieve this exascale level of connections, and that's not just within the data center white space, but it also looks at the data center interconnect and really creating this global network to facilitate the swiftness that the data transfer that is required to achieve the AI capabilities.
Okay, I think that's covered most of the questions I had around it. So at least for now, Andrew, really appreciate your time. Thank you very much indeed. Thank you.
Thank you very much as well. Pleasure to be here.